Welcome to the lecture series of Basic Electrical Engineering. The subject code is ACE 101. The topic of today's video is Fundaments of AC Circuits. AC and DC currents and voltages. It is known that the polarity of DC voltage and direction of DC current are always same. That is, it is a unidirectional value which does not change the polarity as well as the direction as shown in this figure. This shows the diagram of direct current in which we are having a voltage source and a resistance and the direction of the current. The direction of the current remains same throughout the circuit based on the polarity of this voltage source. Unless these polarities of the voltage source are not changed, the current directions remain same. But on the other hand, alternating current or voltage is one which regularly changes its direction as well as its values. Or alternating current is a type of current which flows first in one direction and secondly it flows in the opposite direction. In each cycle it changes the value from 0 to maximum and again hit the 0 value. Alternating currents gives us the positive and negative peaks in each cycle. The first half it is in the positive cycle and in the second half it is in the negative cycle. So according to the positive and negative cycle, the directions of these currents are changing. Second term is what is RMS or the root mean square value. The RMS or root mean square value, also known as effective or virtual value of an alternating current, is the value of direct current when flowing through a circuit or resistor for a specific time period and produces same amount of heat which produced by the alternating current when flowing through the same circuit or resistor for a specific time. This figure shows the RMS voltage. This shows the waveform of one cycle, this green waveform of one cycle, and this shows the RMS value which is equals to IRMS is equals to IM. IM is the maximum value of the current upon under root 2. And the voltage RMS is equals to Vm upon under root 2 and I is equals to 0.707 into Im and voltage RMS is equals to 0.707 into Vm. Vm is the maximum value of the voltage in this waveform. So capital I or the IRMS is the indication of the RMS current and capital V or the VRMS is the indication of RMS voltage. Keep one thing in your mind that whenever we are measuring the current on the ampere meter or on the voltmeter, when it is connecting to a AC circuit, it always gives us the RMS values of current and voltages. Next term is average value. What is average value? If we convert the alternating current sine wave into a direct current sine wave through a rectifier, then the converting value to the DC is known as average value of that alternating current sine wave. If the maximum value of the alternating current is I max, then the value of the converted DC current through the rectifier would be 0.637 Im, which is known as the average value of the AC sine wave and it is denoted by IAV. Average value of current is equals to IAV is equals to 0.637 Im. As shown in this figure, this shows the average value. It is equals to the peak value or the maximum value of the voltage into 0.637. The next is instantaneous value. The value attained by an alternating quantity at any instant is known as instantaneous value. It is denoted by small I or small e. As shown in this figure, at the different values of time, at T1 we are having the different voltage, T2 we are having 5.1 volt, at T3 we are having 8.9 volt. So this T1, T2 and T3, these are the instantaneous values. Next, what is peak voltage or maximum voltage value? As shown in this figure, this shows this maximum value or the peak value. It is the maximum value in the positive half cycle. When we find the maximum value between 0 to pi, the maximum value is that pi by 2, and in the negative cycle between pi to 2 pi, the maximum value is 3 pi by 2. So definition: peak value is also known as maximum value, crest value or amplitude. It is the maximum value of alternating current or voltage from the zero position, no matter positive or negative half cycle, in a sinusoidal waveform as shown in this figure. It is expressed as Im or Em or Vp. Vp means V peak value, and the equation of peak voltage is given by Vp peak voltage is equals to under root 2 into Vrms is equals to 1.414 RMS, or Vp is equals to pi by 2 into V average. This is in the terms of RMS value, and this equation is in the terms of average value, and this shows the in terms of peak to peak value. Peak to peak value means from this value to this value, from positive half cycle to the maximum negative half cycle. Here we are having the definition of peak to peak value. The sum of positive and negative peak value is known as peak to peak value. It's expressed as IPP or VPP. The equations and formulas for peak to peak voltage are as shown in figure. V peak to peak is equals to 2 under root 2 into RMS value. This is in terms of RMS value, and VPP is equals to pi into V average. This is in the terms of average value, and this is peak to peak in terms of peak value, means 2 into Vp, means here we are having 1 Vp and this is second Vp, so it becomes, the total will become 2 Vp. The third term, next term is what is peak factor? Peak factor is also known as the crest factor or the amplitude factor. It is the ratio between the maximum value and RMS value of an alternating wave. Peak factor is equals to RMS value upon peak factor is equals to maximum value upon RMS value. It for the sinusoidal alternating voltage, it is Em upon 0.707 Em is equals to 1.414, and for the sinusoidal alternating current, it is Im upon 0.707 Im is equals to 1.414. So peak factor is equals to 1.414 in the case of voltage and current. What is form factor? The ratio between the RMS value and the average value of an alternating quantity, current or voltage, is known as form factor. It is given by RMS value upon average value. So it is written as 0.707 Em upon 0.637 Em, or it is in the terms of current, it is written as 0.707 Im upon 0.637 Im, and its value is 1.11. So form factor is equals to 1 0.11 in the terms of voltage or current. Some more terms related to the AC circuits. The first one is the waveform. The path traced by a quantity such as voltage or current plotted as a function of some variable such as time, degree, radian, temperature is called waveform. Cycle. One complete set of positive and negative values of alternating quantities such as voltage or current is known as cycle. The portion of a waveform contained in one period of a time is called cycle. A distance between two same points related to a value and direction is known as cycle. A cycle is a complete alternation. So these are the different ways of defining a cycle. Period. What do you mean by a period? The time taken by a alternating quantity such as current or voltage to complete one cycle is called its time period, and it is denoted by T. It is inversely proportional to the frequency f and denoted by T, and its units are in seconds. T is equals to 1 by f. So frequency, the next term is frequency. It is the number of cycles passed through per second. It is denoted by f and has a unit cycle per second, and that is hertz, Hz. The number of completed cycles in 1 second is called frequency, and it is given by f is equals to 1 by t. Then amplitude. What do you mean by this? The maximum value, positive or negative, of an alternating quantity such as voltage or current is known as its amplitude. It is denoted by Vp, Ip, or Emax or Imax. Then alternation. One half cycle of a sine wave, whether negative or positive, is known as alternation, which span is 0 to 180 degree. Now this diagram shows all the terms. First of all, on x-axis we can take the values time, omega, or the angle, or the temperature, and on the y-axis we are having the variables like voltage or current. So this green complete waveform, this shows one complete cycle. Here it is from 0, pi and 2 pi. This is 0, pi and 2 pi, and this is pi by 2, and this is 3 pi by 2. So if we are talking about the peak value, this is our peak value, and relative to 0, this is called Vp or Ip. It is also called Imax or Im. Then next term is the RMS value. This shows the RMS value of this waveform, and it is given by the Vrms is equals to peak voltage into 0.707. Then the average value, I have given you the definition of average value. This is the average value, and it is also given by VAB is equals to V peak into 0.637. Fine. This is one complete cycle, and this is called alternation. This is for positive alternation, and this is negative alternation. So these all are the terms, and this is frequency is equals to 1 by t in hertz, and this is the one complete time period. This is the periodic time T. So these are the terms which we are having in the AC fundaments. I am quickly go through the slides which we discussed today. First we will give the basic difference between AC and DC, then RMS value, then average value, instantaneous value, peak voltage or peak values, peak voltage or peak current, then peak to peak voltage, then peak factor, form factor, and terms related to AC circuits, waveform, cycle, period, frequency, amplitude, alternation. So this is all about today's lecture. Hope you like it. Thank you very much.